All right, so things are starting to get a little messier here. We have a second degree numerator and a fourth degree denominator. Always my first step with these will be to try to factor. So that numerator actually factors into an x plus 1 times x plus 1. So I'm getting an x plus 1 squared, which means I'm going to have to think about multiplicity. In the denominator, that looks pretty rough, but I can factor out a 2 and an x squared from everything, and I think that will make things way easier to deal with. So I'm left with an x squared plus 2x minus 3. And I can actually factor that a little bit more. That will be an x plus 3 times x minus 1. So I don't get to cancel anything, which means I don't have a hole in the graph, but I do have to think about the multiplicity in the top and in the bottom. And just in general, a big warning is that when you factor out x's, for whatever reason, those don't stand out as much to people, and they will forget that that does give you a 0 or a vertical asymptote or a hole in the graph, depending on where it shows up. So looking at this, zeros happen when the entire function is equal to 0, which means the top has to be equal to 0. For fractions, the only way to make them 0 is to make the top equal to 0. In this case, that happens when x equals -1. And I'm going to make myself a note here because that will have multiplicity too, which means the factor won't change signs. Even if x plus 1 switches from being negative to positive, by the time you square it, it stays positive the entire time. So we will not see a cross through at that x-intercept. We'll see a bounce off. Vertical asymptotes. There are actually 3 factors that I need to be worried about. There's the 2x squared, the x plus 3, and the x minus 1. So 2x squared will equal 0 if x is equal to 0. X plus 3 will equal 0 if x is -3, and x minus 1 will equal 0 if x is 1. For holes in the graph, we already said nothing looks like it's going to cancel, so there are none. For my global behavior, I'm looking for that horizontal asymptote versus slant asymptote versus none of the above. In this case, I already said I have a second degree numerator and a fourth degree denominator. What happens here is that the 2 out in front doesn't even end up mattering. What we're really going to look at is just the fact that if you plug in a large number like a million and square it, if we're starting with 10 to the 6, we'll get 10 to the 12, versus plugging in 10 to the 6 and raising it to the 4th power and getting 10 to the 24. The bottom is so much bigger than the top that even the 2 becomes negligible. So this is going to behave like an x squared over x to the 4th, which is really like having a 1 over x squared. And if you let x get really, really, really big, dividing by a massive number makes things really tiny. So this does have a horizontal asymptote, but it's at y equals 0, which can only happen if the degree on the bottom is bigger than the degree on the top. So we do not have a slant asymptote. This bottom list, you can't have both. It's one or the other, or neither, but not both. So let's go ahead and start trying to sketch. I am seeing 0 at -1, so we're going to cross. Nope, we're going to bounce off the x-axis at -1. We have lots of vertical asymptotes in this one. As your degree gets higher, you'll see more of these. X equals 0, x equals -3, and x equals 1. That's a little skinny one. Okay, I think I captured all of that. Oh, and then a y equals 0. These are always the trickiest, I think. When your horizontal asymptote is on the x-axis, it makes it a little trickier to decide whether you should be starting above or below. So this is one of those times where I'm just not feeling confident. I'm going to use one other point. Anything smaller than -3 seems good to me. I'll choose -4. And I'm going to use the factored form. So I'm actually looking up right here. It just seems like it'll be a little easier for me to figure out whether it's positive or negative. So I get a -3 squared on the top, which is 9. On the bottom, I get a 2 times 16, And then negative 4 plus 3 is negative 1. And negative 4 minus 1 is negative 5. So what I'm really interested in here is whether it's positive or negative, and I see two negatives in there that'll cancel. So this is greater than 0. You can plug in a calculator and get the actual output. That's fine, but really all I care about is it positive or is it negative. So we're a little ways above the x-axis. It looks pretty close, but a little ways above the x-axis out here, which means I'm going to start above because we have two things happening. Yes, the horizontal asymptote is there, but all that really tells me is to put this arrow here. The other thing happening is that because it's on the x-axis, we actually do know that we only get to cross the x-axis once, and that is at negative 1. So I need to start above and stay above the x-axis, which is going to force me to head to positive infinity. Okay, so negative 3, let's look at these. We are on this factor right here, which did have multiplicity 1, which means the signs will change. Odd powers don't get rid of negative signs for you, so you will have to switch from positive infinity to negative infinity. And then our next piece of local information is an x-intercept at negative 1. That did have multiplicity 2, which means I am going to bounce off of the axis. And then since I'm not allowed to cross again, I'll be forced to head to negative infinity as I approach that vertical asymptote at x equals 0. Let's see. Multiplicity. Okay, so the vertical asymptote at x equals 0 came from this factor right here, and it did have a multiplicity of 2, and what that tells me is that the factor won't change sign. So if I was headed to negative infinity, I'm going to match that on the opposite side. So even powers for those asymptotes mean that you will mirror the direction on the two sides of the asymptote. And I'm going to head up for a little bit, but I don't get to cross the axis. My next piece of local behavior is actually another asymptote, and since I'm not allowed to touch the axis, I'll have to just turn around and head back down before I even get there. And this is another piece that technology sometimes hides from you. You can have a pretty good viewing window and see most of what's going on, but this might be way down in the big negative numbers, and you might not be able to see it unless you know to go looking for it. So with rational functions, we could actually write down a domain here. The domain is that x can't be 0, and it can't be negative 3, and it can't be 1, which means that I'm implying that absolutely every other x value works. So there should be something going on your graph for every x value except those vertical asymptotes. All right, not quite done in that same spirit. We have one more side of an asymptote to look at. We have the far right to look at. So x equals 1 came from the factor x minus 1. So odd multiplicity means we'll switch directions since that has an odd power. And then I'm not allowed to cross the axis, but as I head out the far right side of my graph, I do have to approach that axis. So it's just going to look something like that. So they can get fairly messy. This is about as messy as what I think we need to bother looking at. What I think is more important than really struggling with terribly messy graphs is just really thinking carefully about why the multiplicity matters, about what each factor is contributing. So whenever a factor gets very close to 0, it starts to take over and be really important in terms of the behavior of this fraction. So keep thinking through that. Don't hesitate to plug in numbers and see what's happening. And again, never a bad idea to just double check with technology and see what you're getting and compare to your graph.